Good morning, students. Can we start a presentation?
Yes, sir. Yes, sir.
Okay, before going to this topic, I'll give a brief introduction about what we seen in the last class and how it is related to this one. In artificial intelligence, we have two types of searches. One is informed search, another one is uninformed search. First, you want to know what is meant by uninformed search and what is informed search. Before proceeding with this, we have to know why we are coming for searches. We have already seen that we have designed an agent, designed a simple reflex agent or model-based agent or goal-based agent. After designing this agent, we want to make the agent to solve some problem. To solve that problem, we need searching algorithms. For that only we are using two types of searches. One is uninformed search, another one is informed search. What is the difference between uninformed search and informed search? Why we want to go for this searching algorithm? Uninformed search does not have any prior information. Uninformed search is also known as brute force search, and it is known as blind search. Informed search is known as heuristic search. It is based upon the heuristic function. It has a prior information about the searches, and you know what to do and how to search. This is the informed search. Another one difference is in uninformed search, the searches goes to infinity or it goes to a loop. But in informed search, we can get the solution. And the optimization of informed search is better than uninformed search. In uninformed search, we have breadth first search, depth first search, iterative deepening search, uniform cause search, and bidirectional search. These searches are all we have seen in the last class. Now we can see the informed search algorithms. What is by informed search and how this informed search works. In informed search, we have greedy best first search, A star search, and we have local search algorithms. Okay, as far as the syllabus is concerned, in Unit 2, you have informed search strategies, greedy best first search, A star heuristic function, local search algorithms. You have constraint satisfaction problem, backtracking in constraint satisfaction problem, local searches for constraint satisfaction problem, structure of problem, adversarial search, alpha beta pruning, and the decision trees, game decision trees, and the element of chances. This is a very important unit. As Unit 1, Unit 2 also is very important. It's a base for artificial intelligence. Okay, now we're going to see what is meant by informed search. We already seen uninformed search. And uninformed search, we have breadth first, depth limited search, iterative deepening search, bidirectional search. Comparison of uninformed search with informed search is very, very important question. Distinguish the difference between uninformed search and informed search. Point number one, uninformed search is known as brute force search, or it may be called as blind search. Informed search is known as heuristic search. Uninformed search does not have any prior information. Informed search has a prior knowledge about the search. Number three, optimization of uninformed search is maximum. Optimization in informed search is minimum. Now we can see in detail about informed search. Today we are going to see greedy best first search, A star search, and admissible in A star search. Admissible A star search is there. Admissible A star search is very important. Greedy bus first search and A star search is very, very important searches. 16 mark questions will come in this greedy best first search and A star search. Before proceeding with this one, I'll tell you how to write this greedy best first search and A star search. If it's asked in the examination point of view, for you, they will not give a problem. They will not ask you to solve greedy best first search or A star search or any of the uninformed search. They will not ask you the problems. But they ask you to explain in detail about greedy best first search, A star search, admissible in A star search. Okay, now we're going to see how to write in examination if they ask this type of searches. Then I'll explain in detail about yes, greedy best first search and A star search. Informed search algorithm. First, you have to know what is. First, you have to write what is informed search. What is the heuristic function involved in it. Then you have to write greedy best first search. You have to write what is greedy best first search and what is the heuristic function involved in this one. Greedy best first search algorithm, advantages, disadvantages, example. In example, you have to write this problem and you have to explain in detail. Then you have to write the time complexity, space complexity, completeness, and optimality of this particular algorithm. It's clear. Now we're going to see what is the advantage of using best first search. Best first search can switch between breadth first search and depth first search by gaining the advantages of both algorithms. This algorithm is more efficient than breadth first search and depth first search. Disadvantages, it can behave as unguided depth first search. In worst case scenario, you can get stuck in a loop as depth first search. This algorithm is not optimal. Okay, now we're going to see, before we have seen what is advantage, what is disadvantage. Now we're going to see what is best first search algorithm, how to do this best first search algorithm with this example. Okay, students, please listen this very important search. Without understanding, you cannot write in this examination. So please make down. If they have any doubt, you can ask me. Okay. Now we are going to go for greedy best first search. Best first search is invented by greedy. So it is named in the name of the inventor, greedy best first search. Okay. Now this is a graph given and this is a table given to you. Now using this graph, I am going to reach from source to destination. This is a goal state, this is a source state. How I am going to perform from source to destination using best first search. Now here you have a table node of n, h of n. This will be given in your question. But as far as your exam is concerned, you have to write this one. You have to draw the graph and you have to explain. Here I given the nodes, all the nodes I specified here. We have node A to A, B, C, D, E, F, G, H, I, S, G. We have all the nodes. I have written all the nodes here. Here h of n is given. H of n, what is meant by h of n? H of n is known as distance from source to destination. If I am having a node S, what is the distance between the node S to the goal node? It is given in the table. Suppose if I take a node A, the distance from node A to reach directly to the destination is 12. Suppose I take 12 kilometers, it takes 12 kilometers. Node B to G, it is 4. C to G, it is 7. This is known as heuristic distance. This is only the prior information given. In uninformed search, this information will not be given. In informed search, this information is given. This is known as heuristic distance or distance to the goal node. Distance from this node to this, distance from this node to this, distance from the node C to G, D to G, E to G, F to G, H to G, and I to G is given. Now here is a distance from S to A is 3, S to B is 2, A to C is 4, A to D is 1, B to E is 3. This and all is given for you. Now can we go for the best first search? Till now, is there is any doubt for you?
Sir, the cost of each node will be like will be like writing of our own, sir. Like it will be given already.
This will be already given.
Cost, sir.
We are asking the cost from S to A,
Ah, yes, sir.
S to B.
Mm.
It will be given.
Okay.
This cost will be given. This cost is also will given. The cost from source to destination will be given. The cost of each node also will be given. Your job is to find the optimal path using best first search. Okay, you have to find the
Yes, sir.
shortest distance or optimal path. Okay, till this, if there is any doubt, what is h of n? What is node of n? Ask me. This is a question. Till now, we have seen only the question part. We didn't go for the solution part. Is there any doubt? Here, G is 0. Distance from goal to goal is 0. Yes, it's understood.
Yes, sir.
Can we go for the problem?
Yes, sir.
Somebody said no, sir. What is the problem there? Mansoor,
Sir, no
what's the
doubt,
problem with
sir.
this one? Huh?
She meant no doubt, sir.
What doubt, pa?
He said no
This
doubts,
what doubt you
sir.
have? Okay. Now can we see the solution part? What is best for search and how we are going to solve this one? Okay, this one is very important. If you have any doubt, please ask me. Now, I am starting from the source node. Yes, I have to put a table like this one, open, close. Okay, what is the open means open node, close means closed node. Here S is closed, so I am writing this S here. S is closed node. What is the open node here? We have two nodes B and A. So I am writing the node B, comma A. Okay. B, comma A, and this is S. This represents a closed node. This represents the open node. Okay. Now we have two ways to reach the goal. One path is by A, another path is by B. Either I have to go by A or either I have to go by B. So if I want to go by B, what is the distance from B to the goal node? B I have 4, A I have 12. It's correct? It's correct. Distance from B to
Yes, sir.
G is 4 and distance from A to G is 12. Okay. So I am taking the minimum distance as D. So I am starting my exploration from B. So here I have the open node as F, comma, E, comma, A. And here I am moving this S, comma, B. What I did here is I shifted this B to here. I shifted this B to here. Okay. Why I shifted here? Listen here. This is a source node. This is a destination node. I have to put the table as open and close. Open node, closed node. For this, S is already closed, so I put yes. Here I have two ways for exploration. So I have B and A I have put in here. From B to the source, the goal node, distance is 4. From A to the destination is 12. I have to take the minimum, so I have taken the minimum. So I have, my exploration starts from B. So I move this B to the closed node and I start from E and F. So I put F, E and A. Now the distance of F is, what is the distance of F here is 2. Distance of E is 8. Which one is minimum? Which one is minimum? Which one is minimum?
Sir, can you repeat again, sir?
Ah, yes. Now this is a graph given to you and this is a table given to you. This table represents the distance of the each node to the destination. This is a cost given for the node. For the node S, what is the cost is 13 to reach the goal. For the node A, the cost given is 12. For similarly, for this all the nodes, this cost is already given to you, and the cost of each node, cost between S to A, S to B, and B to E is already given. Now you have to do the best first search strategy to find an optimal solution to discover the path. So what I did is I have used two table. I have put on table. The fields are open and closed. Open represents open node. Closed represents closed node. What is a closed node? Closed node is after this I cannot do anything. So S is yes, after I have only two possible solutions with S. Either I can move through A or I can move to B. So I put S here in the closed node, and in the open node I have put B and A or A and B. Now I am seeing the distance cost of B to G and A to G. B to G is 4 and A to G is 12. So here the minimum is 4. So I am going my exploration through this side instead of this. I am not going to follow this procedure, this type, this one. Why I'm not following this one? Because here the cost is more. So I am following this path. So B is minimum. So I am going to this side. Now I have to take whether E or F. So F2 goal node is 2, E to goal node is 8. Which one is minimum? 2 is minimum.
Yes, sir.
So I am going for F. Now I am having the two nodes I and G. I is 9, G is 0. So I am going for 0. So I reach the destination. Have you understood?
So how we are considering S as a closed, sir? Can you explain, sir?
Now take this graph. Okay. How many possible ways are there to go to the goal node?
Only two possible.
Only two paths is there, A, B.
Yes.
After this, there is no path.
Hmm.
It's correct.
Yes, sir.
So the path is I wrote here. A, B, I already wrote. Is there any other path after this one?
No, sir.
So I am taking only the exploration node here. So I put here yes.
Okay.
Okay, now I am taking this. I have find the minimum here. So I am taking B. So hereafter I am not going to go for B. Hereafter I want visit yes. So I mark it as closed. Okay, in this step hereafter I want visit B. So I mark B as closed. Hereafter I want visit F. So I mark F as closed. Now it's understood?
Yes, sir.
Is
So
it
why you are
clear?
marking that as closed, sir? Because from F we are going to the goal state now, sir.
Yes, F here is the goal state now.
Hmm. So
After this
we have to
one,
close
I
it,
have to
sir.
move this F here. I have
Hmm.
to move the F also to here. After moving F only, I am having two options, I and G. I have to find which one is minimum in I and
Okay.
G. Then G is minimum. So what I have to do, I have to move this G here.
Yes.
Okay.
Yes, sir.
Now G is also closed. I already reached the goal. So what is the path here? S, B, F,
F,
G is the
G.
path.
So one more doubt I'm having, sir.
One second. This is my path. Okay.
Yes, sir.
Now I explain another one time. Then you ask your doubt. Okay. All the students, please listen this one. This is very important topic. In 16 mark, they will ask you to write greedy bus for search or A star search using admissible A star search. Three questions are there. It is very, very, very important. If they ask this question, you have to write like this way. First, you remember to write this answer. First one, you have to write what is best first search, what is the heuristic function involved in it, what is the algorithm, what are the advantages, what is the disadvantages, example with this graph, this table, and how you are exploring this path, and how you got this one. This one you have to explain like this given in the notes. Then you have to try the time complexity, space complexity, completeness, and optimality of this algorithm. Then only you will get the 16 marks, full 16 marks. Okay. Here in the any of the book, if you study, they will not give this explanation like this way. Okay, as I written here. So you follow this step, then it will be easy for you. Now I am dealing with an example. This is a graph given. This is a table given. The table here is node h of n. H of n is the distance from the source to destination for each node is given here in the table. Similarly, the cost or path cost of each node is already given. Now you have to follow the greedy best first search strategy to find an optimal solution. This is our goal. The heuristic function involved is f of n is equal to g of n here. So we are going to see how to reach this. We have marked as open and closed nodes. Put a table, mark as open and closed. The closed means that after this, there is no exploration of among this node. So I am taking this graph. In this, I am starting with the source S. If the source A is a source, then you have to start from A. Here it is clearly stated that S is a source. So I am stating as S as a root node. What are the possible ways here? I have two possible ways to move. Either I can move left or I can move as right. The path to itself is 0. So there is no path to itself. If I go to here, what will come? If I take a path like this, it goes for an infinite loop. Okay, so I'm not going for this one. So I'm taking any left or right. Now I have to find which one is optimal path. So I am taking the left side B, right side B, left side A. So the distance from A to B to goal state, A to goal state. A to goal state is 12, B to goal is 4. The minimum here is 4. So I am moving this way. So what I am doing is, this node, I have visited already this node. So I am marking as S. The node I am going to visit is A and B. So I am writing here A and B. In this I have found B is minimum. So hereafter I won't visit B. So what I am doing is I am going here moving B to closed node. So why I am writing this as closed? Because I want to write the path, which path I have to write. So that only after S I have to go to B. Why I am not writing this one? B, A it is coming. This and all. Only the steps I am following. Which one is minimum? For that only I am doing this one. If I write this one only, I'll know the path. So I am going marketing as closed. So hereafter I want visit B, I go for E and F. I find which one is minimum here using this table. Now I found F is minimum. So I have moved F here. Now I find which one is minimum, I, G. G is 0. So 0 is minimum. So I mark G here. So my path is S, B, F, G. So what is the cost involved here? For S, B, G, F, G. The cost is 13 plus 4 plus 2 plus 0, which is equal to 19. Correct. So the total cost is as total distance. If I take the path from S to G is minimum optimal path using best first search is 19.